Hello team, today we're going to have a look at fire safety. So today's topic is going to cover various general things around personal fire safety, fire equipment, that kind of thing, and perhaps a few things we need to understand as electricians around working with and around fire safety systems, I guess. So, straight into it. Key points. Fire is a hazard that must be constantly guarded against. Fires may originate due to combustible materials being subjected to high temperatures or be caused by arcing or overheating due to electrical failure. Faulty electrical appliances, accessories, apparatus and their flexible cords can cause fires. Loose or improperly made electrical terminations, worn or damaged insulation, overloading or improper use are frequent causes of electrical fires. So look, that's something that we need to be really aware of as electricians, right? That our work can cause fires if it's not done properly. I think we're all aware of that in general, that overloading of things, particularly the old multi-box, you put too many things on the multi-box and that can cause overheating and lead to fire. That one's a pretty generic one that it's reasonably well communicated out in the world, that don't overload multi-boxes. People are aware of that, but also our work can lead to fire. If we don't do things well, then we can overload circuits or cause hotspots that may start a fire. And while we're talking about that, so what are we talking about here? Why does overloading things or bad connections cause heat and potentially fire in the future? Now, if you think about we've talked before about the concept of resistance. What is resistance? If you have current flowing through a wire, it's going to cause heat. It will always cause heat. There'll be heat caused by current flow through a conductor. Now, the greater the resistance of that conductor, the more heat that will be generated. It's dissipating power. It's consuming power as heat. So if we have bad connections, if you have a connection inside a light switch or a socket that's only hanging on by one thread of your copper wire, then that little single thread is going to be carrying the whole current for the circuit, and you're likely to get hotspots or high temperatures where that tiny little thread of cable is, and that's something that can cause a fire. When we're talking about overloading on a multi-box, that's just the amount of current that we're pumping through that multi-box. If you think about the fact that a single outlet on the wall is good for 10 amps, and then I plug in a multi-box with 4 plugs on it, and I can plug 4 appliances in there, I could easily draw much more than 10 amps, and that's going to cause heat in that circuit, because nothing on that circuit is rated for greater than 10 amps. And that's going to cause us a problem as well. It could potentially lead to a fire. And then the third one is when you do connections, if you make a bad connection, this happens particularly in switchboards, then you're likely to have your cable loose in there, and that can move due to vibration or what have you. That moving cable then is going to cause arcing. Every time it makes and breaks connection, you're going to get a spark in there, and then that spark could cause a fire as well. So these are the things that we need to be aware of and guarding against as electricians when we're doing electrical work. So the fire triangle. Now, in order for a fire to be present, or a fire to something to catch fire, we need to have 3 things. We have to have heat, we have to have fuel, and we must have air or oxygen. If you think about it, we think about fire as a thing, but it's not really a thing. Fire is a chemical reaction. It's a chemical reaction between oxygen and whatever the material is, the fuel. And usually what happens is through that chemical reaction, oxygen binds with the molecules of whatever that is, causing a third compound to be created, and that's what we think of as ash or the carbon deposits or whatever that is left behind after a fire. So that's the interaction between oxygen and that material. Now, that interaction is going to, at a chemical level, is going to be greatly increased by heat. The more heat we put into that oxygen and whatever it is reaction, then the faster that reaction will occur, and one of the byproducts of that reaction is then more heat, which continues the fire. Oxygen reacts with lots of things. Rust, for example. Rust, if you analyze the chemical composition of a piece of rust itself, it's iron oxide. So what's happening there is the iron is reacting with oxygen and they're binding together, and that creates a third compound, which is rust. So if you think about it like that, you could say that something iron, steel rusts because it has iron in it. But there's something steel that is rusting is kind of burning in very, very, very slow motion. But essentially it's the same reaction. It's oxygen and the material, in this case iron, or if we're talking about a fire, it could be wood or whatever. It's that reaction that's happening, and it's creating heat. Fire extinguishers. Portable fire extinguishing equipment provides a ready and effective means of attacking and extinguishing incipient fires. We mean small fires or beginning fires, thus preventing serious damage and loss which would result if the fire were to develop. Fire extinguishers must be simple and ready to operate so that any person who's in the vicinity of the outbreak of a fire can use it most effectively before the fire has time to gain a hold. All staff should be trained in the use of extinguishers. Yeah, there's a little bit of debate around that one. Obviously, my last job before I was a lecturer, I worked in the fire industry as the manager in or we would call it a fire company, but it's an inspection company for building warrants of fitness. And building warrant of fitness stuff is mainly around fire protection and fire evacuation. So all the inspections that we did were on various fire systems within those buildings. Now, fire extinguishers are no longer required by law. They used to be. It used to be required by law, and part of your building warrant of fitness that you must have firefighting equipment on site. And by that we mean fire extinguishers and also fire hose reels, which you'd see around the place. The old red cabinet that you open, it's got the fire hose inside. So those used to be required, but they no longer are. And in fact, I'm aware of some places that have deliberately not installed fire equipment or even removed that kind of fire equipment, extinguishers and so forth, due to what they felt was a risk that people would feel like they can fight a fire, that their first reaction to a fire would be to try and put it out, and that may put them in further danger. Whereas if you don't have that fire equipment, then everybody evacuates the building. I mean, for the purposes of this, that's neither here nor there. If fire extinguishers exist on site, then we should be aware of them, make note of where they are, what type they are. We'll cover that in detail shortly. Obviously not all fire extinguishers are useful for all types of fire. So if we've got fire extinguishers, if there's fire extinguishers in your workplace, you should be aware of them and know what they're used for and how to use them. Dry powder fire extinguishers. Now these are by far the most common ones that you're going to come across. Identified by a white band. They have a simple method of operation. You pull the pin out. That's at the top here. So they usually have the little yellow tie. You just break that. The tie just stops the pin from falling out. So you break the tie, pull the pin out, squeeze the two handles together, and it's going to fire high pressure dry powder out of the hose there. There are three main types of powder commonly referred to: monoammonium phosphate, that's ABE, and sodium potassium bicarbonate, which is BE. Little bit of trivia there: the ABE fire extinguishers, that the powder that's inside them is actually a pretty good fertilizer. So I know fire technicians often, if they get hold of dry powder fire extinguishers that are expired or broken in some way, they'll take them home and spray it on their garden, and works. It's a pretty effective fertilizer. It's not on purpose, obviously. Nobody designed fire extinguishers to be able to spray on your garden, but you can use them for that as well. So ABE dry powder fire extinguishers are suitable for all types of fires except cooking oils and fats. A BE dry powder extinguisher are suitable for flammable and combustible liquids, flammable gases, and electrically energized equipment. So we've got a couple of things we need to be aware of there. I'm sure you've all come across the idea that we shouldn't use water on a fire that involves oil or fat or anything liquid. The reason for that is those things float on water. So you pour the water on top, the oil floats to the top of the water, and then it's likely to spread even further as the water runs around the place the oil or fat would go with it. When you're using a dry powder fire extinguisher, most fire extinguishers, if we remember that fire triangle, fuel, heat, and oxygen, what we're doing with the dry powder is putting a layer of powder on top of the fire itself, and therefore depriving it of oxygen. There are two main ways that you could extinguish a fire if you think about that fire triangle. The first one is smothering that fire, so this is what the dry powder extinguisher is doing. Covering the fire with something, that's what we mean by smothering, covering the fire with something in order to starve it of oxygen. Once there's no oxygen coming into that reaction, then the reaction will cease. And the second main way that we do it is by cooling it. If we can cool that fire down to the point where it's no longer combusting, then obviously it's going to go out. So certainly when we're talking about the dry powder, we're mainly talking about smothering. If you're talking about pouring water on a fire, it's doing a bit of both. On the one hand, we're trying to stop oxygen getting in there with the water on top, but actually the main way that water is extinguishing a fire is by cooling that fire down. In either case, with water, you certainly can't put that on oil or fat. And then of course at the bottom there it says that we could use dry powder on electrically energized equipment. We have to be aware of what type of extinguishers we're using around electricity. If you've got an electrical fire caused by a short circuit or something like that arcing, then pouring water on that is going to cause us some problems. It may put out the fire, but obviously water is a conductor, so what you're going to do there is pour water onto a live circuit, and that water that you pour on there is going to become live, so you're potentially creating another hazard. So although water may be an effective way of putting out an electrical fire, it's going to create other hazards, so we certainly don't do that either. Just be aware with the dry powder, if you're using that on an electrical fire, it's going to create a hell of a mess. That dry powder is pretty nasty stuff. You certainly don't want to be breathing it in, and then once you're finished with it, you've got to get rid of it all, and it is an absolute nightmare to clean up. It sticks. It's very, very fine dust and powder. It's quite sticky, very hard to remove. So if you're going to spray that inside a switchboard, you might end up rebuilding that switchboard. Carbon dioxide, so it's identified by a black band, suitable for use where the fire is located close to electrically energized equipment as they are non-conductive. So the carbon dioxide is not going to create a hazard by conducting electricity when we spray it. They're not the most effective option, and they may also be dangerous in the case of fires involving cooking oils or fats. So let's think about CO2 then and how that prevents a fire. So we're also here talking about starving the fire of oxygen. If no oxygen can get to the fire, then that reaction will cease. CO2 is effective at displacing oxygen. Obviously we can't breathe CO2, it's going to push the oxygen away. So what are the issues there? What are the upsides, downsides? So the upside of that is it's good for use on electrical equipment because it's non-conductive. We can spray it onto the equipment, remove oxygen out of that reaction, and then we're not going to leave a big mess like we would with a not going to leave a big mess like we would with a dry powder fire extinguisher. It's certainly not going to cause us the same amount of issues in terms of the cleanup, because the carbon dioxide will eventually dissipate by itself. Let me just check where I'm at. Okay. So some of the issues there, it's not the most effective thing, as it says here, not the most effective option, and that's because if you think about it, when we fire, say, dry powder onto a fire, like I said, it creates a layer of powder on top of the fire and thereby reduces the ability for that fire to get oxygen. If you talk about carbon dioxide, there's no way to make that carbon dioxide stay where you have sprayed it. It's a gas, it's going to go everywhere. While you're spraying the CO2 onto the fire, then that continuous stream of CO2 across it is going to stop any oxygen from getting in there. And hopefully the idea there is that it puts the fire out pretty fast. But if it doesn't put it out and then you stop, then that fire is going to come back again because the CO2 will slowly dissipate. Although maybe not immediately. And if you think about that, spraying that CO2 and it going everywhere, you probably realise what some of the other hazards are, and one of those is going to be the fact that, particularly in a smaller enclosed space, like a switchboard room, for example, if you wandered into a switchboard fire and the switchboard, it was say a big building with a switchboard room, so you start spraying that CO2 around, and then not only the fire will be deprived of oxygen, you might be deprived of oxygen as well, which is not going to be a good look. So we don't, because then the fire probably won't go out and you'll fall over dead, and then you'll get crispy fried while you're having a nice nap on the floor. So we just need to be aware of that hazard as well. But generally we're talking about that, as I say, that continuous spray is what's going to put out the fire, not just squirt the CO2 and then CO2 in the atmosphere extinguishing the fire. It's the actual stream. And then it says at the bottom, may also be dangerous in the case of cooking oils and fats. So again, we could extinguish the fire by spraying the CO2 on it, and the CO2 displaces the oxygen around that fire and therefore puts it out. But if you think about it, it's coming out as a pretty high pressure jet of gas coming out of the extinguisher, and so in the case of a fire on liquid like an oil, that could fling that oil all over the place. You can imagine say spraying a high pressure air into a bucket of water, water's going to flick everywhere, and it's the same thing if we spray high pressure CO2 onto a liquid fire. That liquids could spray everywhere, and then you've got a bit of napalm on your hand and on your hands, and then it's obviously going to continue to catch fire wherever that stuff lands. So there's a few issues with CO2 fire extinguishers, but you will often see them around switchboards because they're probably the safest one to use for an electrical fire. Water fire extinguisher. So this is just a steel cylinder full of water and pressurized, so that when you pull the lever, it's going to spray water out. So they have no color band. They're very rare to find and banned in some areas. Very simple method of operation. Only really suitable for tackling freely burning materials such as paper, cloth, wood and furniture. Should not be used against flammable liquids, flammable and combustible liquids, for example oil and petroleum, or cooking oils or fats, as the water will merely spread the flames. Yeah, so the water ones are not really an effective option, right? We're definitely not going to use them against oil and fat fires for exactly that reason. It's going to spread, the oil will float on the water and it goes everywhere. And then secondly, we're not going to use them on electrical fires because as I said earlier, that will create an additional hazard. Might put the fire out, but will create an additional hazard of having water in our switchboard, water flowing everywhere, and that water being a conductor that could be live. So we may save ourselves from the fire and then end up electrocuting ourselves. So a water extinguisher, if you've got a fire in a rubbish bin or something like that, it's probably not too bad. But you can still use a dry powder or a CO2 extinguisher against those kind of fires too. So water fire extinguishers are fairly rare, as it says there. We don't often use them. In fact, I can't tell you the last time I came across one. Certainly by far the most common are going to be your CO2 and your dry powder, and in fact dry powder is a lot more common than CO2 as well. Foam extinguishers and specialized foam, identified by a blue color band. Again, simple method of operation: pull the pin, pull the handle. Ideal for fires involving flammable liquids. It is dangerous to use foam extinguishers on live electrical equipment. Right, so this is you might find these in commercial kitchens or something like that. So they have the advantage of the dry powder in that what they're doing is they're smothering that fire, so it fires out. What we've got in there is there's no actual foam in there. The foam is created as a reaction between two compounds, so they're released when you open that valve, and then it expands very rapidly into a very light foam which will sit on top of the fire and smother it from oxygen like the dry powder. The advantage of the foam over those other types of extinguishers is that that foam is quite light and it will sit on top without displacing a liquid. So you can spray it on top of an oil fire, and it's not going to shoot that fire everywhere or spread it like we saw with those other types. So foam ones are really good for flammable liquids. Again, it's dangerous with electrical equipment because that foam may be conductive, and therefore we don't want to do that. Once again, like with the dry powder, clean up on these ones is going to be a bit of a nightmare, although the foam does kind of dissipate. Foam fire extinguishers, I don't think I've seen too many of them. You will get foam sprinkler systems, which I have seen, which is a similar idea, but instead of water coming out of your sprinklers, it's a foam type of material. In fact, I've worked in a building where it had a foam system, but we might talk about that a little bit later. Wet chemical extinguishers, identified by an oatmeal colour, so it's that kind of mustardy colour on there. Simple method of operation, again, same as before. They're ideal for freely burning materials such as paper, cloth, wood and furniture, and with cooking oil and fat. Oh, excuse me. They're not suitable for use with flammable and combustible liquids like oil and petroleum, or flammable gases. So now it's saying that cooking oil and fat is okay, but not oil and petroleum. So we'd have to be, if we were using a wet chemical extinguisher, we'd have to be really aware of what type of fire that we're looking at. It's again dangerous with electrical equipment because it would be conductive. Again, I have not seen many of these. In fact, I don't know if I've ever seen one of these. They would, the fact that you can use them on certain oil fires but not others would tell me that that's not something that we're going to use in general use. It would be likely to be highly specialised in that if we had a wet chemical fire extinguisher, it would be for a specific purpose in a specific location because of the specific hazard that's present in that area. So classes of fire. Class A is solid materials like paper and wood, textiles, fabrics, that kind of thing. Class B are liquid, petrol, oil. Class C with gases, so hydrogen, propane. So we're talking about like barbecue cylinders, that kind of stuff. Gas fires are likely to be incredibly dangerous. They probably carry the additional hazard of explosion because anytime you've got a gas, it's probably stored somewhere under pressure, and if you catch fire on or around a high pressure gas cylinder, it's probably going to explode at some point. Class D are fires involving metals. So some metals can catch fire: potassium, magnesium, and sodium. Magnesium's a common one. You might have seen that in science class when you're at high school or something. You get that magnesium ridamine and you set it on fire. Something to note about that is it can maintain that reaction without a oxygen source. So you can stick a piece of magnesium that's burning into water and it will continue to burn. Sodium is one of the constituent parts of salt. It's technically a metal, although it comes in kind of yellow clumps. Something interesting about sodium is if you stick it in water, it'll explode. You can probably find a video of that on YouTube if you search water sodium explosion or something. There's plenty of that kind of stuff out there. Potassium, magnesium both burn very, very hot, very, very bright. So they're often used in military applications. If you've ever seen the flares that we fire up and that kind of thing, they're usually a potassium or magnesium sort of fire, or phosphorus is the other one that you use for that. Class E are fires involving electricity, and Class F are fires involving cooking fats. So we need to be aware of what type of fire extinguisher is appropriate for each of those classes of fire. And if we look here, we can see a little table here that will tell us. If you look at those symbols at the top there, so A, we've got that was the loose material. B was your fuel type ones. C was gas. D was, actually let me skip back and have a look. C was gas, D was metal, that's this one here. E was electrical, F was cooking oils and cooking fats. So you should see then on fire extinguishers these kind of symbols that will tell you what fires that particular fire extinguisher is useful for. And if you look here, it tells us which type of fire we can, which type of extinguisher we can use on each type of fire. So for a Class A, that freely burning materials, we can use nearly all of them except probably carbon dioxide. For your fuel type fire, we can use foam, dry powder, CO2, or a fire blanket. So a fire blanket is just literally a blanket made of a fireproof material that you can put over the fire, and again that smothers the fire. Again, this is a fairly common one in commercial kitchens. You'll often see, in addition to an extinguisher, there'll be a fire blanket in a little packet mounted on the wall somewhere, and you can rip that out, throw it across the top of the stove if your pan has caught fire or something, and then you don't have that risk of that fire getting thrown around by the high pressure material that you're firing out of an extinguisher. For our gas fires, we only want to use the dry powder. For our metal fires, looks like we're out of luck. None of these, we do not have any fire extinguishers in normal circulation that are appropriate for use on metal fires. Electrical, we want to use dry powder or CO2, and then for the cooking fires, it's either wet chemical or fire blanket. So you can see there that dry powder, and I said before, dry powder is probably the most common. So you can see there it's by far the most versatile. One. CO2 follows that, being, although not as versatile, it covers off probably our two most common, or at least our most dangerous ones, which is going to be fuel and electrical. Fuel here and electrical here. So a little bit more then on fires with electrical equipment, because obviously that's something that's important to us as electricians. Fires in or adjacent to electrical equipment may be dealt with by any of the following three types of fire extinguishers: carbon dioxide, dry powder, and vaporizing liquid. I don't think we saw vaporizing liquid before. Let me just scroll back. It's electrical. Okay, so we didn't talk about vaporizing liquid. Not something that I've come across. So generally we're talking about carbon dioxide and dry powder. When to use an extinguisher? Only when it is absolutely impossible to isolate the supply beforehand and the fire presents serious and imminent danger. Should any attempt to be made to extinguish the fire with the supply alive. So we obviously then, in any case that we want to fight a fire that is on electrical equipment, we should try and turn that thing off. If we can isolate the supply to that before we start to attack the fire, we definitely should do that. We should only attack that fire if we absolutely have to. And don't forget to call the fire brigade before the fire gets out of control. If you're going to go up and fight that fire, then maybe get somebody else to call the fire brigade while you're doing that. How to use the extinguisher. The typical steps for operating a fire extinguisher are described by the acronym PASS. So P, pull the safety pin. A, aim the nozzle at the base of the fire. So remember, the flames itself are not the fire. The reaction is happening where that fuel is. So we want to get to the base of the fire or to the fuel itself. We need to be from a safe distance. S, squeeze the handle. So we're grabbing the two handles at the top, squeezing them together. And then the last S is sweep the extinguisher from side to side while aiming at the base of the fire, so that we make sure we cover the entire thing. Fire cells, right. This one is something that's high up on my list. So having worked in that fire industry, and as I said, we're involved in the inspection of buildings for warrant of fitness purpose. Fire cells are by far the most attacked fire system, if you like. Attacked might be the wrong word, but if you think about a fire alarm or a sprinkler system, nobody's mucking with that sort of stuff generally. We know what a fire alarm or a smoke detector or something looks like when we see it, and random people aren't generally going to go and pull those down. Same with the sprinkler system. We can see the red pipes, see the sprinkler heads. We don't want to muck with that stuff, and the majority of people don't. Actually, the only time I've come across people mucking with the sprinkler system, and it's hilarious how dumb it is, but when I was working in the fire industry, two of our contracts were, we had the contract for New Zealand Police buildings, and we had the contract for the court system, or Department of Correction and Justice. So they generally have sprinkler systems in their buildings, including sprinkler heads in the cells. And I cannot tell you how many times we had call-outs to go and fix up the sprinkler system because a prisoner in the cell, particularly people who were short time, like they're in the courts or police stations, they're bored and dumb, I guess, and they break the sprinkler heads, which might be the stupidest thing I've ever heard. What is funny about that is generally the cops or the corrections officers, the guards who are supervising those people, once they've figured out that there's no fire and that person has actually damaged the extinguisher, the next thing that will happen is the fire brigade will attend. When the extinguisher goes off, the fire brigade are automatically called, so they'll turn up, ascertain that there's no fire, and then switch off the main valve for the sprinkler system, and then that's when we would come in, fix up the sprinkler head and turn everything back on. So once the guards or the cops have figured out that there's no actual fire and the person has just damaged that themselves, generally what they'll do is leave that person in the cell. and they can just have a nice cold stinky shower for the duration until the fire brigade turns up. So I don't know what most of those people expect to achieve, but it's certainly fairly common that people in cells want to damage sprinkler heads and get a bath. And just one further note on that, and it's a good one to remember, a sprinkler system is made up of steel pipe. It's charged all the time, which means there's water in there, just like there's water in the tap at your house. As soon as you open that sprinkler system, it's coming out. Now the water that's in those pipes has generally been there since that sprinkler was installed, and it's just inside steel pipes and it just sits there. So sometimes you might have water in a sprinkler system that's been sitting there for years, in some cases many years, and it's never been emptied. So when you open that valve, you're going to get a burst of all of the black stinky water that has been sitting in those pipes forever, and it is black and stinky. Again, if you go online and have a look for videos of sprinkler systems going off, you'll notice that when that sprinkler head activates, you'll get a burst for a few seconds of it looks black, and then you'll start to see clean water coming through. Because it is black and it sits in there and it stinks. It is the foulest, most vomit-inducing thing that I've ever sniffed in my life. And as I say, if you find yourself in a cell and you think you want to tamper with a sprinkler system, not only are you going to get a nice cold shower, it's going to smell. It's going to be foul. So anyway, fire cell. Yeah, now the reason I would say that fire cells are attacked or damaged is because a fire cell within a building generally means some sort of, well, we also refer to them as fire separation. So we're talking about walls, part of the structure that is fireproof, or at least fireproof up to a certain point. They're generally rated in hours. So you have a 1 hour fire cell or a 2 hour fire cell, depending on how they're constructed. Most tradespeople, and I will put my hand up and say until I worked in the fire industry, the idea of fire cells never entered my head. No one ever explained it to me. But obviously we go around and run cables through walls and ceiling spaces and that sort of stuff. And there's lots of other people who do that too, telecom type people, that running internet cables, phone cables, anyone who's running pipe work, so gas, water, so plumbers, that kind of thing. We all want to run services through buildings. And if you put a hole in a firewall, what you're doing is compromising that fire cell. So you're creating a point at which fire may be able to spread and get through that wall or through that fire cell. So that creates a real hazard. So that was always a big deal in the fire industry, that when we went and did the annual inspection of the fire cells or fire separations, if it's a big enough building where people are coming in and out all the time, you'll always find new holes, fresh holes in your fire cells. And it's quite a specialised job to patch that up. You've got to use the correct materials. It's got to be done in a certain way because you have to maintain the integrity of that firewall. It's got to be perfect every single time. So we had a couple of guys who did fire separation work that did like the fixing up, and boy, they made some money because it's an expensive and labour intensive process to fix up that kind of thing. So a fire cell refers to any space, including a group of common spaces on the same or different levels within a building, which is enclosed by any combination of fire separations, external walls, roofs and floors. The purpose of these cells is to prevent the spread of fire by trying to keep them in one area. Proper design of a building can limit the spread of fire both within the building and to other buildings. So the most common place that you'll come across a fire separation is in floors, the floors between separate levels on a building. So the idea there, of course, is that if we have a fire on the bottom floor, say the second floor, then the people on the above floors are going to be able to get out before that fire threatens the floors above. So if you think about P block at MIT, it would be, the floors would be fire separations. Generally they'd be fire separations by design. They'd be made out of concrete, so concrete by itself is an effective fire separation. But any services that come up between floors will generally be all together. So you'll probably find there'll be a service cupboard somewhere, and that will have access up and down, and then that cupboard itself will be enclosed by further fire separations. So if there's a fire on one level, it's not going to penetrate into that service cupboard and then upwards to the next floor. So there'll be a fire separation around what you'd call the service cupboard or service shaft going from top to bottom. You'll also find that the stairwells would be enclosed by fire separations, so that no fire in any floor is going to spread into the stairwell, because that would potentially affect the evacuation of people on the floors above. So that's where we would usually find fire cells. Now, fire cells are not fireproof. A fire that's hot enough and long enough is going to get through there eventually, but the idea, as I said before, they'll be rated to a certain period of time, 1 hour, 2 hours, something like that. The theory behind it is that that prevents penetration of the fire into through a fire separation into another fire cell, which would compromise evacuation. So if we've got fire cells between floors in a building, fire separations between floors in a building to keep each floor as a separate fire cell, fire separations enclosing the stairwells, which would prevent fire spreading into the stairwells, and then fire separations around our service shaft or service cupboards to prevent fire going into those and then being able to get up to other floors. That's why you'll see, again, if you think about MIT, the P block, the doors into the stairways, you'll see they've got that really thick safety glass, which is part of the fire separation, and the door itself. And you'll also find that those will be labelled that would say fire door, do not hold open, or something like that, because in the event of a fire, obviously that door is probably the most obvious place where the fire would spread through from one fire cell to another. So it's absolutely no good if somebody's got to run around and close all the doors if there is a fire. So they'll generally have an automatic closer on them, and they won't have a hook that you can use to keep them open. They'll be closed all the time. And there's obviously special construction of those doors as well that means that they're fireproof, or at least for a period of time. All right, automatic fire extinguisher systems. Automatic fire suppression systems control and extinguish fires without human intervention. Examples of automatic systems include a fire sprinkler system, gaseous fire suppression, and condensed aerosol fire suppression. I think one of the next slides talks about this a little bit more, but in short, I'm sure you're aware of what a sprinkler system is. So a sprinkler system is a network of pipes throughout a building with little heads on them that spray water out when they're penetrated. The way that those work is the head itself is held closed, or the valve on the head is held closed by a little vial with a liquid in there. When that liquid gets hot, it expands and it smashes the glass tube that it lives in, and when the glass tube is smashed, that opens the valve. So each sprinkler head is rated to a certain temperature. The most common ones are 57 degrees. So 57 or 61. There's a few different types you can get depending on the situation. Normally you wouldn't put a 57 degree head, for example, in a ceiling space, because ceiling space can get very hot, and we wouldn't want the sprinkler system going off just because it was hot up there and there was no fire. You also, if you think about that, you'll realize that unlike the movies where all the sprinklers go off at once, each individual sprinkler head has its own glass tube and its own valve. So you smash one of them and that one will open. If the fire has spread further, then each of those sprinkler heads will activate individually when they reach the correct temperature. That's really uncommon. A sprinkler system is an incredibly good, a very, very effective way of suppressing fires. I've seen some videos of some pretty heinous fires, and then once the sprinkler operates, they disappear. The fire goes out very, very quickly. In fact, one, I might try and find it and share it with you guys, but there's one that I saw that was in a supermarket warehouse, and they had pallets of toilet paper stacked up almost to the ceiling, and by the time that fire starts to spread, obviously big stack of toilet paper is going up pretty quick. So by the time the sprinkler goes off, that pallet or those pallets of toilet paper are burning furiously, and yet the sprinkler puts it out literally within seconds. Pretty much as soon as that sprinkler goes off, the fire goes out pretty quick. Fire alarm systems. So A fire alarm system will detect a fire using smoke detectors, fusible links, and glass bulbs. So a fusible link is a little bit of wire that will melt at a certain temperature, so that would open or close a circuit and send a signal back to the fire control panel. They will summon the fire brigade. They'll notify occupants that there's a fire and to commence evacuation of the building. In a fully automatic fire alarm system, they will operate an extinguishing system. Okay, so a few points there. So generally you have heat detectors and smoke detectors. Again, they'll be for different purposes. Smoke detector will detect smoke. A heat detector will detect heat. Usually, for example, you won't have smoke detectors in a kitchen because the steam or what have you can, or a bit of smoke from burnt toast or something can set off a smoke detector, and you don't want the fire alarm to go off every time somebody burns toast. So generally there you'll have a heat detector, which is the fusible link type. So once it gets to a certain temperature, the little bit of metal melts, and then that's what sends the signal to the control panel. Now it says there's will summon the fire brigade. It won't always summon the fire brigade. There are certain situations where they must be connected to the fire brigade, and that's a communication system that's all of its own, by the way. So the fire alarm system that's connected back to the fire brigade is totally separate generally to your other phone systems or anything like that on site, and they're connected directly to the fire brigade. So when that signal comes through, the fire brigade gets a notification, and they know exactly what building it is and all of that sort of stuff. They will always notify the occupants, so that's your alarm going off, whoop, 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 or ring, 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 whatever it is. And they may also be, as it says there, operate the extinguishing system, or they could also be connected to other things. So an example would be buildings where you have swipe card access in and out. Often those swipe card systems will be connected to the fire alarm. So if the fire alarm goes off, the fire alarm control panel sends a signal to the controller for the swipe doors saying it's a fire, unlock every door, and then all the doors unlock, so people don't have to swipe their cards to get out of the building. Although there's some rules around swipe cards as well, in that you're only supposed to it's only supposed to control access into a room, and you shouldn't have to have a card to get out of a building. It should be freely open on the way out. But either way, sometimes the fire alarm is interfaced with the automatic doors. So the fire alarms will generally have the fire alarms have the capability to trigger and activate other systems. What else? I'm just trying to think. Is there anything else that a fire alarm may be connected to? Obviously connected to fire brigade, connected to the doors, could be connected to an extinguishing system. Yeah, not sure. Fire sprinkler system. So as we talked about, then we've got a really good picture there of a sprinkler, and you can see the little bulb with the liquid in it. So that bulb there is holding the valve closed at the top. Once the liquid reaches a certain temperature, it expands, smashes the glass, water comes spraying out. And then this little bit at the bottom here, the little star-shaped thing, that's not where the water comes out. The water comes out at the top. What the star-shaped thing does is just creates a spray. So the water will come straight down, hit that little star-shaped bit at the bottom, and that spreads it out. I don't think there's anything there on that slide that I haven't already mentioned. Yeah. And then we have gas systems. So gas fire suppression is a term to describe the use of inert gases and chemical agents to extinguish a fire. The system typically consists of the agent, it's the chemical agent, whatever it is, agent storage containers, agent release valves, fire detectors, fire detection system, agent delivery piping, and agent dispersion nozzles. An extinguishing system which primarily is based on inert gases in enclosed spaces presents a risk of suffocation. To prevent such occurrences, additional life safety systems are typically installed with a warning alarm. Yeah, so gas systems like this are not that common. The places where I've mostly come across them is in telecommunications, so Chorus, Spark, that kind of thing. They have a lot of these in their buildings. Where a sprinkler system would not be effective or would present other hazards. So in the case of Chorus, for example, Chorus owns about 900 buildings all around the country with all the telecommunications equipment. That's what keeps your internet going, your phones working, cell phones, all of that sort of stuff. So you can see in this photo here, it actually looks like a data rack of some description here. You also see gas systems in data storage places, so data centers that are literally buildings that just have hard drives in them where banks or the government or whatever store information. People rent those, and it's probably the same as like your Google account or your iCloud account. That storage is happening physically somewhere. It's not on your phone, it's stored in the cloud, but that cloud exists somewhere. It's a hard drive somewhere, and companies like Google and Apple own massive buildings just full of storage, data storage. So in those types of places we would use gas suppression as well, rather than sprinklers. Why? Because a small fire will cause some damage to equipment, but if that sets off a sprinkler system and you spray water all through that building, then you're just essentially going to destroy everything. You might as well let it burn, because the water will do just as much damage as the sprinkler would. So what we have here is a gas system instead. It looks very similar to a sprinkler system, but obviously instead of water coming out and instead of being connected to the main water supply, it will be connected to gas bottles, just like we've got here, this picture here, the two red gas bottles. So that gas is obviously a non-flammable gas. That makes sense. You wouldn't want to spray, methane or something onto a fire. It's just going to make the fire bigger. So it's an inert gas. It's usually CO2, or there's a few proprietary type chemicals that they use with various things in them. I can't think what they're called off the top of my head. Never mind. It's going to spray gas. Now that works it's similar to the CO2 fire extinguisher in that it's depriving the fire of oxygen, but it doesn't work in the same way like a CO2. As I said, it's going to spray the extinguisher is going to spray CO2 straight onto the fire, and thereby as it moves over the fire, displacing the oxygen. In a CO2 or in a gas fire system, it's going to fill the room with that gas, and then obviously there's no more oxygen left, so the fire will go out. As it says there, that causes or creates a risk or hazard of with regard to asphyxiation or suffocation. If you're in that room when the gas system goes off, you're going to die 100% of the time. We've got a very short period of time to get out. So generally those gas systems won't go off immediately, so they're not like as soon as the detector goes off it fills the room with gas. They usually have a delay time on them, so you have some quite complicated gas control gear associated with them. So an alarm will go off, and usually it'll be a spoken voice alarm, and it'll say fire, please evacuate the building, the gas system is about to go off, and it might have a countdown until that gas system goes off. If you hear that, you need to be out of that building, because once it goes off there's no stopping it. The valves are usually like a detonator, so they actually fires. You can't reset them, you can't turn them off. Once that detonator goes and it fires that valve open, it's destroyed. So all of the gas is coming out all at once, and there's no way to stop it, so you need to be out of that space. I haven't heard of too many fires causing gas detection or gas suppression systems to go off, but I've certainly heard of people doing inspections and repairs on gas systems, accidentally setting them off. And the last one that I know of wasn't the company I worked for, was one of our competitors, which made it even funnier. But they set off a gas detection system at a Chorus building, or a Spark building, I think. One of the big terminals up on the North Shore. I think the one where the Pacific cable comes. There's a big internet cable that comes from America. So there's a big terminal there. It's really expensive. They definitely don't want fire, so they've got a gas system in there, and one of the guys doing the inspections actually set it off, and it costs about $30,000 to get new gas bottles in there. And obviously evacuated the building, and all sorts of horrendous things happened. So the biggest thing to be aware of is if you come across these systems, don't touch them. Don't touch them unless you know what you're doing, because if you set one off, it's going to cause a whole massive domino effect that you cannot control. There's no going, oh, whoops, I pushed the wrong button, turn it off. Like I said, once it detonates, that's it. It's over. They're going off. There's nothing you can do about it. Fun, right? All right. That is the end of that slideshow. Pretty short and sweet. We'll talk more on this one in our conference call because it is an interesting topic. I mean, there's so much going on. Obviously, I've had experience in that industry, so it's something that I like to talk about and share experiences. So I've got a few stories that no doubt I will tell on our conference call. Bring your questions because this will be one of those topics. Every lecturer has strengths and weaknesses, things they know a lot about, things they don't. Fire systems is probably one of my big strengths. Fire systems and anything electrical on a fuel or hazardous area type site. Those are the two that I know a lot about. So if you want to know more about fire systems, I've got all sorts that I could talk to you about. So for the purposes of what we're doing, this is all you need to know. But for our conference call, bring your questions. Thanks, Steve. Great job.